So today we got interrupted by a fire drill. So you want to look at two things when you look at the domain of a function. The first thing is to look at the denominator, right? Denominator can't be 0, so x in this case cannot be equal to 1. And the second thing is you want to kind of get whatever is underneath that radical and say that must be positive, right? So I'm going to say, or actually it could be equal to 0. So I'm going to say 3 minus x, similar to what we've done before with the radicand there, is either bigger than 0 or equal to 0. And then just solve that. So I get negative x squared equal to negative 3, x, 3, change the direction of sign, or divided by negative. So I've got really both of those things happening. If you want to look at that answer on a number line, it looks something like this. There would be a closed circle of 3. Kind of goes here, it hops over the point at 1 and keeps on going forever in that direction. That's the domain of this function. All values where x is smaller than or equal to 3, but not equal to 1. Let's just look at this one. If you graph this in your TI Nspire, you get a line that looks like, let me show you. So you get a graph that looks like this, and what you can't see from the graph, at least not at the initial look, is it kind of looks like the domain is all reals. It looks like this certainly does go up and forever to the right and down and forever to the left. Let's just algebraically solve this. If we do that, we get x times x minus 2 over x minus 2, the quantity. And if you cancel there, see that those two values cancel, and we just get f of x equals x, which is why that graph looks like the line y equals x there. But you notice, look at that denominator. There's a value that's going to make that not true. And so if you look at trace, hit menu 5, 1, and if I type in 2 and press enter, it shows me that there is in fact a hole right there. 2 is undefined, and so there's a little teeny tiny hole. So when you draw that graph by hand, make sure to put a little teeny tiny hole right in there. It's going to look something like that, where there's a little hole in there. So there's something called a hole in a graph you'll see occasionally that could come into play. Let me hit one more thing before I go on to the next thing with piecewise functions. Just want to make sure, if you have a function like this, f of x equals, let's say x squared minus 5. If I want to find f of, say, 2x, wherever there's an x, I'm going to plug in 2x. So my answer would be 4x squared minus 5. Just for fun, let's find f of 3 plus x. In that case, again, we're basically plugging in for x. Everywhere there's an x, we're going to plug in 3 plus x in this problem. So in parentheses, I have 3 plus x squared minus 5. Well, if you FOIL that out, that's a binomial squared. You get 9 plus 6x plus x squared, and then minus 5 is still tacked on the end there. If you put that in the right order, you get x squared plus 6x plus 4. That's going to be your answer. Same thing here. This is your answer there. Your answer is, if you plug x in, you're probably going to get x out with the input-output the way a function works. So don't be scared of answers that look like that. That's definitely possible in your homework. These are called piecewise functions. And so there are two functions. There's two separate functions here. And there are pieces of each. So I have this function, the x squared function. And then I have the x minus 3 function, which is linear, and this one's quadratic. So I'm going to graph all of x squared here. So I'm going to graph 0, 0, 1, 1, 2, 4. If I plug those values in, 2 squared is 4, so I plug 2 in, I get 4. Negative 2 squared is also 4. Pretty soon I've got this graph looks like this. You'll get familiar with this graph. It's one of our graphs we see very often. Now, The tricky part is I don't want all of that graph. I only want the part. This is the domain right here. These are the only x values I can plug into this graph. X is less than 1 or equal to 1. So I really want to eliminate or erase some of these others. X, this is the x-axis here, so x is 1 right here. So everything where x is bigger than 1 needs to go away. And so there at 1, that's going to be a closed circle because it has an equal sign right there. And then if you do this one, we go x minus 3, that's y-intercept of negative 3, slope is 1. It's going to look something like this, roughly. And then I don't want all that graph, my domain. I only want the part where x is bigger than 1. Well, get your eraser out. I only want this part where x is bigger than 1. All this part to the left here, I really don't want. In fact, at 1, you need to be careful there. You should have an open circle because that does not have an equal sign underneath. And you can see this graph will never overlap vertically. See how if I had that line there that this graph would overlap vertically? That's not good. It's never going to do that. Functions never do that. So my graph is in two pieces, hence it's called the piecewise function. We're going to do more of this in the second lesson, so don't be too scared if you didn't get it the first time. I want to show you one example, but I think in your homework they have some examples where you plug in to piecewise functions. So just understand, there's really, there's a function right there and there's its domain, right? We've got a function right here. Here's its function, here's the domain, right? And then you got a third one here. Here's the function, and here's the domain of that function. So when I have g of 1, I've got to figure out which domain it fits into. And so 1 is bigger than or equal to 1, so this one fits into this function right here. So I'm going to plug into that function. There's three functions plugged into. I'm going to plug this one into that one. So I get negative 1 plus 6, which is 5. Then you go to negative 1 here. Negative 1 seems to fit into this domain right here. So I'm going to plug into here. But there's no x value to plug into, so I just get negative 5. That's just kind of by default. That's the way that works. G of 2. If I plug 2 in, 2 is bigger than 1, so I'm going to go ahead and plug into this one. So this would be negative 2 plus 6, which is 4. So I can put a 2, I get a 4. And you can keep going there. Let's do one more at least here. So 0 is right in between negative 1 and 1. So on this one, if I plug into here, I get 0 minus 1, which is negative 1. And that's how you handle piecewise functions and plugging in defined function values.